In the vast, seemingly endless expanse of the cosmos, stars have long been the anchors of their planetary systems. Around them, worlds spin in predictable orbits, bathed in their sun's steady glow. Yet lurking in the dark shadows beyond these luminous centers, there exist mysterious wanderers, planets adrift, unbound by any star. These are the rogue planets, cosmic castaways drifting alone through the cold abyss, unseen and largely unknown. Unlike the worlds we cherish in our own solar system, these rogue planets are exiles of the celestial order, cast away by violent gravitational forces, or perhaps born in isolation, never tethered to a star's comforting light. The story of rogue planets begins with the understanding that planetary systems are not always stable. In the tumultuous early days of star formation, swirling clouds of gas and dust collapse under gravity, forming new stars surrounded by disks of material. Within these disks, planets take shape, growing from dust grains to massive bodies. Yet this process is chaotic. Interactions between newborn planets, gravitational tugs from passing stars, or the upheaval caused by a star's evolving life can eject a planet from its home orbit. Imagine a world flung into the void, losing the warm embrace of its star, cast into eternal darkness. Scientists believe that rogue planets are surprisingly numerous. Estimates suggest there could be as many rogue planets in our galaxy as stars themselves. Yet their detection is a challenge. Without a parent star to illuminate them or provide gravitational clues, these lonely wanderers remain invisible to most traditional observation methods. Instead, astronomers must rely on subtle signs, the faint infrared glow from their residual heat, gravitational lensing effects when they pass in front of background stars, or unexpected distortions in spacetime. The search for rogue planets is a hunt for shadows within shadows, for worlds that silently traverse the galaxy's cold corridors. But what is life like for a rogue planet? Deprived of stellar warmth, the surface of these planets is an unforgiving realm of darkness and cold. Temperatures plummet to near absolute zero, a frozen wasteland under an eternal night sky. Yet this bleak picture does not tell the whole story. Some rogue planets may harbor internal heat, generated by the decay of radioactive elements or the slow release of gravitational energy as their cores contract. This internal furnace could create pockets of warmth, perhaps sustaining hidden oceans beneath thick ice layers, similar to some moons in our solar system. In the desolation of space, these internal flames offer a flicker of hope. The idea of rogue planets stretches beyond mere astronomy. It challenges our very concept of habitability and life's resilience. Could these dark wanderers, isolated and adrift, still nurture some form of life? What forms might such life take, evolving in perpetual darkness, relying not on sunlight but on chemical energy? These questions push the boundaries of science and imagination, inviting us to reconsider what it means to be a world and what it means to survive against cosmic odds. As we deepen our exploration into these dark frontiers, new technologies and telescopes promise to reveal more about the rogue planet population. Missions like the upcoming Nancy Grace Roman Space Telescope and advanced infrared observatories will sharpen our ability to detect these elusive objects. Each discovery will peel back another layer of mystery, transforming the unknown into the known and expanding the horizons of our cosmic neighborhood. Rogue planets are not just scientific curiosities. They are symbols of cosmic freedom and solitude. They drift unbound by solar chains, silently witnessing the grand ballet of galaxies and stars from the shadows. To understand them is to glimpse a different kind of planetary existence, one that defies our expectations and beckons us to imagine worlds beyond the familiar in the endless dark between the stars. To comprehend the true nature of rogue planets, one must first imagine a world completely severed from the comforting warmth and illumination of a parent star. Without a sun, these planets are cast into the profound darkness of interstellar space, a vast expanse where temperatures plummet to levels that defy human imagination. The familiar cycles of day and night vanish, replaced by eternal night, a cosmic shadow where light is no longer a source of energy, but an absent presence. On these lonely travelers, the surface is frozen solid, a barren wasteland sculpted by the cold and the unrelenting vacuum of space. Yet beneath this bleak exterior, rogue planets may harbor hidden realms of possibility. The absence of sunlight does not necessarily equate to lifelessness. Deep inside, radioactive decay within the planet's core continues to generate heat, just as it does within Earth and other rocky bodies in our solar system. This internal energy can warm pockets beneath thick layers of ice, potentially creating subterranean oceans of liquid water, isolated from the freezing vacuum above. Similar to moons like Europa or Enceladus, these hidden oceans might provide refuge for life, sustained not by sunlight, but by chemical energy and geothermal warmth. The notion that life could exist on rogue planets challenges traditional astrobiological paradigms. On Earth, life depends fundamentally on sunlight, which fuels photosynthesis and sustains the food chains we know. But in the dark recesses of a rogue planet, life would need to adapt to radically different conditions. Chemosynthesis, a process where organisms derive energy from chemical reactions instead of sunlight, could provide the foundation. On Earth, deep-sea hydrothermal vents host ecosystems thriving in total darkness, fed by minerals and heat from beneath the ocean floor. If similar processes exist on rogue planets, it is conceivable that life, simple, microbial, or even complex, could persist in these alien oceans. Moreover, the atmosphere of some rogue planets might act as a thermal blanket, retaining enough heat to slow the freezing of surface or subsurface water. Thick layers of hydrogen or other gases could insulate the planet, creating a greenhouse effect even in the absence of stellar radiation. While the surface might remain inhospitable, subsurface niches could provide stable environments where life could evolve slowly, over millions of years in isolation. The drifting nature of rogue planets adds another fascinating dimension to their story. Unlike planets bound to stars in predictable orbits, these wanderers travel through interstellar space, crossing regions filled with cosmic rays, dust, and radiation. This exposure presents a harsh and unending bombardment, shaping their surfaces and atmospheres, and potentially influencing any life forms they might harbor. At the same time, rogue planets could occasionally pass near other star systems, momentarily basking in the warmth of a distant sun before continuing their solitary journey. Such encounters could provide bursts of energy, possibly thawing frozen surfaces or triggering chemical reactions critical for life's development. Even fleeting moments of light might be enough to spark changes beneath the ice, creating dynamic environments on these otherwise static worlds. The potential for life to survive and adapt in such shifting conditions speaks to the resilience and tenacity of life itself, a theme echoed throughout astrobiology and cosmic exploration. Scientifically, detecting signs of life, or even confirming the presence of rogue planets, remains a monumental challenge. Their distance, darkness, and isolation obscure their signals, making them some of the most elusive objects in the universe. Yet with advances in infrared astronomy, gravitational microlensing techniques, and future space telescopes designed to peer into the cold depths, our ability to identify and study rogue planets is rapidly improving. Every discovery adds a piece to the puzzle, hinting at a population of worlds once thought impossible. The mysteries of rogue planets push us to expand our understanding of what it means to be a planet and what conditions can support life. They remind us that the cosmos is far stranger and more varied than the familiar orbits and glowing stars that dominate our night sky. In their darkness, these worlds harbor secrets waiting to be uncovered, secrets that may one day redefine our place in the universe. As humanity's gaze stretches ever deeper into the cosmos, rogue planets emerge from the shadows as a frontier ripe for discovery and imagination. These cosmic drifters, once only theoretical curiosities, have become real subjects of intense scientific inquiry. With each technological leap, from powerful infrared observatories to sophisticated gravitational lensing surveys, astronomers edge closer to unveiling the true nature and diversity of these mysterious worlds. They are the dark wanderers of space, untethered by stars, carrying stories that challenge conventional wisdom and invite us to rethink the architecture of planetary systems and the very definition of a world. Looking ahead, the future of rogue planet exploration is poised for breakthroughs. Upcoming missions like the Nancy Grace Roman Space Telescope and the James Webb Space Telescope, combined with ground-based arrays like the Extremely Large Telescope, will enhance our ability to detect faint heat signatures and gravitational effects caused by these lonely planets. These instruments will not only identify more rogue planets, but may also probe their atmospheres and compositions, seeking clues about their origins and potential habitability. Each new detection is a step toward transforming the abstract concept of a planet without a star into a tangible, studied member of the cosmic community. Beyond detection, theoretical models and computer simulations are reshaping our understanding of rogue planet formation and evolution. Some may be ejected from young, chaotic star systems during gravitational interactions, while others might form independently in the dark depths of molecular clouds, never acquiring a sun. This duality in origin stories adds layers of complexity and intrigue, suggesting rogue planets are a diverse population with varied histories and characteristics. As models grow more sophisticated, they hint at the surprising possibility that some rogue planets could be massive and even host moons or rings, functioning as mini-solar systems adrift in the void. The philosophical implications of rogue planets are profound. These worlds, journeying alone through interstellar space, embody a form of cosmic solitude unimaginable in the familiar confines of our solar neighborhood. They challenge our anthropocentric view that planets must orbit stars, thrive in sunlight, and follow predictable paths. Instead, rogue planets expand the cosmic narrative, reminding us that the universe is far stranger and more varied than our terrestrial experiences suggest. Their existence opens a window into the resilience of matter and possibly life, adapting and surviving even in the harshest and loneliest conditions. From a broader cosmic perspective, rogue planets may also play a role in the galactic ecosystem. As they drift, they interact with interstellar gas and dust, potentially seeding these materials with complex molecules formed on their surfaces or in subsurface oceans. They may carry the ingredients for life across star systems, acting as vectors for panspermia on a galactic scale. In this sense, rogue planets could be silent messengers, spreading the chemical seeds of life through the galaxy's dark corridors. For humanity, the prospect of exploring or even visiting rogue planets remains a distant dream, yet not an impossibility. As propulsion technologies advance and interstellar travel concepts evolve, rogue planets might become targets for exploration missions beyond our solar system's boundaries. These wanderers, free from the constraints of a host star, could offer unique environments for scientific study and perhaps even future colonization. Worlds where the rules are rewritten and the unknown beckons with endless possibilities. Ultimately, rogue planets are more than astronomical phenomena. They are cosmic stories waiting to be told. They embody the mystery, isolation, and wonder of the universe's darkest corners, challenging us to look beyond the light and discover what lies in the shadows. Their silent journey through the galaxy invites us to ponder the vastness of space and our place within it, reminding us that in the great cosmic dance, not all planets follow the same steps. Some drift alone, forging paths through the darkness, eternal wanderers in the infinite night.